Hello, Blue Faculty Mentoring Network participants. This is Deb Linton. I am a co-PI on Blue and a faculty member at Central Michigan University. The purpose of this presentation is to introduce you to the process of designing an educational module using biodiversity data. Some of you selected the option of designing your own module for the FMN. I hope this information will be of specific value to you as we work together through this process. For the rest of you who are adapting and implementing one of the modules we have already developed, I hope this will give you a strong sense of the thinking that has gone into the development of these modules and will provide a foundational framework to guide you as you implement them in your courses. The curriculum development model that we try to follow in developing our materials is the backward design process developed by Wiggins Zimrick Tai. In this model, we first define our learning objectives. That is what knowledge we want students to gain or skills we want them to develop as a result of completing one of our modules. Next, we identify what students would need to be able to do to show us that they had met those objectives. And finally, we design activities that we believe will provide students with experiences while they will learn the knowledge and practice the skills we have identified. However, we have learned that the progression through these steps is rarely strictly linear, and that we often need to revisit and refine our objectives and assessments as we design module activities. Also, we've identified key considerations for each of these steps that must be made in the development of modules using biodiversity data. This figure shows the workflow we developed to represent our process of module development. The shaded boxes identify the 3 stages of the backward design process, and the additional content represents the key issues we wanted to remind ourselves to consider while implementing the process. I'm going to discuss each stage to provide an overview of our process. First, I want to discuss how we identify our learning objectives for each module. The first key consideration in identifying learning objectives for a Blue module is that we want these modules to be integrated into the undergraduate biology curriculum. To make this possible, we need to make sure that the modules are addressing learning objectives that already exist in the curriculum. So we need to look at the objectives for undergraduate biology and identify what subset of those objectives can be addressed using biodiversity data. Then we need to identify which of our learning objectives for biodiversity data literacy align well with specific biology content. 2011's Vision and Change report identified 5 key content areas for undergraduate biology education. Within the content areas of evolution and systems, we believe that there are many learning objectives that could be strongly addressed using biodiversity data. Biodiversity data have a major strength in being able to document change over time in organisms' structures and distributions. Interactions between organisms and their environments can also be investigated using biodiversity data, and we have existing modules we've developed that do just that. Vision and Change also identified what they call core competencies, which they define as sets of skills linked to disciplinary practices, or the skills needed to be a biologist. This is an area that we believe our modules will be particularly strong. All of our modules require students to apply the process of science and use quantitative reasoning, but lots of educational materials out there do that. The special value of biodiversity data is that it is inherently interdisciplinary, requiring collaboration with other disciplines, and is place-based in a way that naturally integrates the relationship between science and society. Of course, the main purpose of Blue is to identify core biodiversity data competencies and get them integrated into introductory biology curricula. So those learning objectives must be present in all of our modules. Blue is working to develop a community consensus on what those competencies are, and in the meantime, we are building modules with basic biodiversity skills that will be foundational to biodiversity data literacy. An excellent example of this type of module is our Data is the New Science module that many of you will be implementing and that we've asked you to work through in preparation for our Week 2 FMN team meetings. The objectives for this module are listed on this slide. The first 2 learning objectives, accessing data and evaluating the utility of occurrence data, are specific to biodiversity data literacy. The next 2 objectives fall into the category of core competencies of using quantitative reasoning and modeling. And the last 2 objectives are core content objectives in the category of systems. So in summary, our vision for the learning objectives for our Blue modules is that each module will integrate biodiversity data literacy with the core concepts and competencies of the undergraduate biology curriculum. Now let's discuss the development of assessments. In this stage, we want to identify what products would provide evidence that students had met the learning objectives. We want to be sure to include both formative and summative assessments, and our key considerations are the time and effort the assessments should take and the alignment of the assessments with the learning objectives. The language of assessment is becoming much more familiar to college instructors, but I want to review these terms just to make sure we are all using them the same way. We can think of formative assessment as checkpoints for both the instructor and the students to evaluate how well students are progressing towards achieving the learning objectives. It's a chance for us to ask, are they getting it? While we still have time to do something about it if they aren't. Summative assessment is an evaluation of how well students have met the objectives after instructional activities for those objectives have been completed. These data are used both for evaluation of students, for example assigning a grade, and also to measure the effectiveness of the modules. If many students didn't achieve the objectives, we have to ask how we can change the module to make it more effective in the future. The most important consideration when designing assessments is that they must be aligned with the learning objectives, both in terms of the content or skills being addressed and the cognitive level. Content alignment is easy. For example, if your learning objective is that students can explain the difference between specimen-based and observation-based occurrence data, then your assessment item for that objective should target that content. Cognitive level alignment is a little bit more tricky. Take the same learning objective. Explain the difference between specimen-based and observation-based occurrence data. If your assessment item for this objective asks students to evaluate whether specimen-based or occurrence-based data should be used to answer a particular research question, then your assessment is misaligned, because this is a higher cognitive level task than explaining the difference between them. Now if you're thinking, but wait, I want my students to be able to answer that question about which type they should use, this is where you're going to need to revisit and refine your learning objectives to make sure that this skill is accurately represented in the learning objectives. One issue that will often arise with cognitive level alignment is that objectives at higher cognitive levels can take more time and effort to assess. Multiple choice questions that are quick to grade might not be able to get you the evidence you'd need for a higher level learning objective, but you won't have the time to interview each of your students to assess their understanding. Performance assessments, in which students apply their gained knowledge and skills to a new case, can be an authentic assessment that can provide solid evidence of understanding with reasonable instructor effort. Here are two examples from the Data is the New Science module. For each objective, students practice skills and answer questions during the classroom activities with the support of teammates and an instructor. This is the formative assessment. Then on the summative assessment, they perform those same skills and answer questions independently based on a case study of a specific plant-pollinator interaction. This next section of the workflow is, for me at least, the most challenging part of the module development process. At this point, we have to identify a specific set of biodiversity data that we will be using for the module and figure out how we want to have students use these data to investigate some biological principle while practicing key skills. Unfortunately, there's no recipe here. This stage requires a lot of searching through databases like iDigBio and GBIF, citizen science portals like iNaturalist and Butterfly, and environmental data sources like the USGS. You have to download data and play around with it to see if it's going to work for your objectives. It's possible to reach this stage and have to return back to the beginning because the data you want don't exist, or at least you can't find them. One tip I can give you is to try to start with some primary literature that used biodiversity data. If a research paper references their use of digitized natural history collections data, for example, you can often have students replicate part of that work in a module. However, this is where I have to disclose a little secret about this workflow. Sometimes the process starts here because we hear about a cool data set and we backward design a module by asking what objectives could we address with this data set. Once we set those objectives, of course, we proceed from there to follow the rest of the workflow, but when we get to this part, we can skip over it because we already have our data set. Now we're finally ready to design and write up our instructional activities. There are two key design constraints on what you can put into a module. The first is how much time the module can take. If you're designing a module for your own class, you need to decide how much time you're willing to allot to the topic. When we are designing modules for dissemination, we try to build in flexibility so that instructors can choose to implement a part of the module in a 50-minute class meeting or all of the parts in a 3-hour lab, for example. A second design constraint is the access to technology. Is there a fast internet connection? Will each student have their own computer? Can the online resources handle the student traffic? Some of these will be implementation issues rather than design issues, but we should still try to keep them in mind as we develop activities. One of the first things you need to decide before beginning to plan the details of a module is what level of inquiry you're shooting for. This table is a nice introduction to levels of inquiry. If we design a module at the confirmation level, we would provide the question that the students would be asking, the method they would use to answer the question, and also the answer itself. This is called a confirmation activity. You may have heard some of these called cookbook labs. At a slightly but significantly higher level of inquiry, we provide the question and the procedure, but students have to perform the procedure and figure out the answer for themselves. This is called a structured inquiry. In a guided inquiry, students have to come up with their own procedure to answer the question that we pose. And in open inquiry, students generate their own questions. Most of our current modules, including the Data is the New Science module, are structured inquiries, but we are also developing materials to support open inquiry using biodiversity data. When writing up the instructions for an activity, we need to consider how the tasks are scaffolded. The first time a student performs a specific task, the instructions need to be fairly detailed. For example, click on the Search the Portal button, or enter your species name in the search box. Remember that if we want instructors who aren't familiar with these data resources to use our modules, we have to make sure they are comfortable with the procedures. Also, when writing up the instructions, don't forget to include your formative and summative assessments as part of the write-up. This is an example page from the Data is the New Science module. Notice that we always start by listing the learning objectives for the module. These aren't secret. We want the students to know what is expected of them. Then we have a short introduction. Be careful not to make this too long or students won't read it. The purpose is just to set the stage and frame the story. It shouldn't read like their textbook. They might not even read one this long, but it's there for them to refer back to as needed. Here's another page from Data is the New Science. For this module, a user guide for the iDigBio website accompanies this handout, so we don't have as detailed directions like where to click. It helps to use headers to make it obvious where new activities begin, and numbering or lettering to show where student answers are expected. We do have a module template that we will share with those of you developing your own modules and anyone else who would like to have it. And now we're ready to implement the module. Whenever possible, try to pilot your module for the first time in a smaller class setting where you are the one facilitating the activity. If all goes well, or with some minor revisions, you should then move on to testing your module with some instructors who weren't involved in the development of the module. This is where you'll really see if your instructions are sufficient for another instructor to implement it successfully. Perhaps you could run a faculty mentoring network where instructors sign up to implement your module and give you feedback. To evaluate the effectiveness of your module, you'll be looking at the summative assessment data to see if your students have met the learning objectives. However, if you want to be able to infer a cause and effect relationship between your module and student learning, for example, if you want to publish your module with evaluation data, you'll need to do pre-post assessments aligned with your objectives and take a look at the effect sizes. Blue is working on designing pre-post assessments of biodiversity data literacy to evaluate our modules, and we'll keep you posted on our progress. And let's be honest, we'll probably ask you to implement them for us in a future FMN. Of course, evaluation data can show you that a module isn't working the way you'd hoped, in which case you can use that data to figure out how to make the module more effective, and then, of course, evaluate it again. So to summarize, we are using the backward design process to build modules using biodiversity data and skills that can be integrated into the undergraduate biology curriculum, so that the next generation of biologists will have the knowledge and skills necessary to use big biodiversity data to investigate issues of global importance. Thank you for joining us in this effort. Be sure to check the agenda so that you can prepare for your next team meeting. We look forward to talking to you then.